What's up everyone, my name is Jason Turley and today I will be showcasing how to exploit a buffer overflow vulnerability on Windows 10 using the VulnServer application. So a quick overview of my setup. On the left hand side I have my Kali Linux VM. This is where I'll be doing all the code and programming to write a script that will exploit this Windows 10 VM I have on the right side. So like I said, the app we'll be using is VulnServer. This is an open source program from Stephen Bradshaw. Just search for VulnServer GitHub and this will be the first link that pops up. We'll scroll down and about the software. VulnServer is a multi-threaded Windows-based TCP server that listens for a client connection on port 9999 and allows the user to run a number of different commands that are vulnerable to various types of exploitable buffer overflows. This software is intended mainly as a tool for learning how to find and exploit buffer overflow bugs, and each of these bugs it contains is subtly different from the others, requiring a slightly different approach to be taken when writing the exploit. Though it does make an attempt to mimic a very simple, legitimate server program, this software has no functional use beyond that of acting as an exploit target, and this software should not generally be run by anyone who is not using it as a learning tool. So long story short, it's a vulnerable web server, TCP. It listens on port 9999, so that's the port we're going to connect to and attack. It's just for demonstration purposes. You're completely safe to use this. Don't run it on necessarily your home computer. That's why I'm doing it in a VM, because it is vulnerable. There's exploits left and right all out the wazoo for this. If you run this, you're likely to become a target, right? If you do it on your home computer or like your production server, this is just a learning tool. We get some links, some write-ups, some walkthroughs on how to exploit the different functions it has, but we're not going to be worrying about that today. It's common knowledge that VulnServer, for the beginner basic buffer overflow vanilla kind of exploit, you want to be attacking the trun function. So you can download it. Just go to code, download zip. I already have that downloaded and extracted, so I'll open it here, go to my downloads folder, click on VulnServer and VulnServer.exe. This window pops up starting VulnServer version 1.1. This is vulnerable software. Do not allow access from untrusted systems or networks. Waiting for client connections. So if I open up a command prompt on my same system, cmd, I can run netstat attack ant p tcp, hit enter. I get a bunch of stuff. Scroll up, I can see port 999 listening on all interfaces. So I want to connect to this just to test. I'm not running any exploit code right yet. Netcat, the IP address of this system, we can see that right here. And then 99999. Smash enter and it connects. It says, welcome to VulnServer, enter help for help. So HELP, enter. Here's the valid commands. As I said before, we want to exploit the trun function. But let me just type trun, and then it wants some type of value. Let's say please sub trun complete. So whatever the trun function does, not really sure, but it's complete. Let me exit out of this. It says goodbye, and over here you can see that it says connection closing. Let me minimize all this. And this is very handy because we have access to the source code. We can see vulnserver.c, so let me open that. And this is the entire server code, right? It's written in C. It's not as easy to read as Python, but if you want to become someone who is a security researcher or who exploits these kind of applications, you need to become familiar with C and C++ syntax. I'm going to be perusing through it. We see that there's 4 function declarations at the top. They each take a character input pointer. So this is probably like an input buffer. This is probably what I'm typing in here. It's probably getting passed into one of these functions. Like I said, we want to exploit the trun function. So Control F, And we can see down here, scrolling down, we get an if statement. So string compare receive buff trun, comma 5 equals 0. Let's scroll up a little bit. So we see a while loop, while C socket, okay. What is the C socket? Scrolling up a little bit more, we see it's the client socket. So that's our connection. So we make a connection and it reads in our input. And then it says, all right, what did they type in? Did they type in help? Did they type in stats? Well, we typed in trun. So here, so when you type in trun behind the scenes, it allocates 3,000 bytes of data on the stack, and it gives that to trun buff. It clears it out, so it sets it to all zeros, and then it iterates from index 5 to the end. So looking over here, index 0 would be T, 1 is R, UN space 5. So it gets everything we enter, so please sub. And it keeps going. If it gets a dot, so if we enter a dot, a period, it'll take all 3,000 bytes or whatever we entered, up to 3,000 bytes, I should say, and it'll call function 3. So what does function 3 do? Control F, function 3. We see it here. It takes in our input and it passes it to buffer 2s. But we see that it's only 2,000 bytes. But I can enter up to 3,000 bytes of data. So it tries to store my 3,000 bytes of data in a 2,000 byte buffer, and it can't fit. It's like overflowing a glass with water. It's going to spill all over the place. So our data is going to spill all over the place on the stack. So we want to figure out how can we exploit this and get remote code execution, get a shell, and get access to the system, become hackers, right? So that's cool, but what do I do, right? How do I get started? It's best to have some type of debugger. I'm using WinDebug, so I'm going to open that up. Hit F6, scroll down, attach it to my VulnServer process, and I'm going to hit G for go. So it's attached here to my VulnServer. The server's running, it's waiting, it wants my connection. So let me open up a Python file. I'm just going to call this exploit.py. Enter my shebang line, user bin env python3. So I need to connect, so I need a socket. Say IP equals 192.168. What was it? That 190.139. The port is 9999. I need to create my socket object. I'm just going to breeze through this first part. If none of this makes any sense whatsoever, I recommend looking up a different tutorial video on, using Python sockets, TCP connection, stuff like that. The focus of this video is just the buffer overflow portion. It's not really going to be on coding in Python too much. So I create my socket object. I call that S. Let me connect. It takes a tuple, my IP and port address. Let me send the trun function, trun space and testing. It's going to give me back some data. Let me just print that out. Open up a new tmux window. Tmux. There we go. That's better. Then exploit. There we go. Python 3. Exploit.py. Invalid syntax. This needs to be a string. Now run it. It doesn't like this. B for bytes. Alright, so it's running. G for go in the debugger. Now let me execute this code. It's going to send trun testing, and then it's going to receive up to 64 bytes of data and then print it out. This is just a test to make sure everything's working. And we can see our response from the server is welcome to vulnerable server, enter help for help, and then we get trun complete. We saw that earlier with our netcat connection. Cool. So if we go back to this C source code, we see that function 3, it can only read up to 2,000 bytes of data, but I'm allowed to pass up to 3,000 bytes. So let me go back to our proof of concept and create a new variable called buffer, and I'm just going to pass in 3,000 A's. If my keyboard works with me, times 3,000, and then instead of sending this, I'm just going to send buffer. Now when I run it and go back to the debugger, I'm expecting a crash. I'm expecting the program to throw an error. And nothing happens. Why? You can see unknown comma, unknown comma. It's probably unknown command, right? I didn't do the trun. I completely left that out. I need to tell it what function to run. So buffer equals B. Let's do it this way. Let's say header is trun. And call this payload equals that. Now buffer equals the header plus the payload. Let's get some debug statements in there. So print sending buffer of size and then the length of the buffer. Clear the screen. Now when I run it, sending buffer of size 3,000 bytes, 2005 bytes. Go here, receive failed error. I see what the issue is. So this function, function 3, it's never getting called. If I can find it. It doesn't get called automatically. We need a period somewhere in there. So what about that? Do you like that? Now when I run it and I look at my debugger, I get a crash, access violation. Cool. So why does this happen? I sent 3,000 bytes, but it can only store 2,000 in its buffer. It's too much data on the stack. It doesn't know what to do, and it crashes. We can see EIP, the instruction pointer. It points to 414141, and that's just the ASCII representation of A's. So we completely overrode it with our A's. We caused a crash. If I do DDS on the stack pointer, we can see A's for days. So this is cool, but now I need to find the offset. How many A's does it take to overwrite the instruction pointer? So I can say MSF pattern offset, or pattern create, MSF pattern create L 3000. So create 3,000 characters. I'm going to copy and paste this in and get rid of my payload. And instead paste in this. All that junk in the trunk. So now it's going to send this unique pattern, right? And then instead of being overwritten with A's, it's going to be overwritten with one of these characters. So let me close out of this and restart the server. Reattach WinDebug. Hit G for go. Save this. Rerun that Python exploit. And it's overwritten the instruction pointer, but now it has 396F4338. So where exactly is that? I can say MSF pattern offset. The length is 3,000. And what I'm interested in is finding this 396F4338. Hit enter, and exact match at offset 2006. So that's how many bytes it takes to overwrite the instruction pointer. come back here, update my payload, A times 2006, and I want to overwrite the instruction pointer with something else. Eventually, I want this to be an instruction to jump back to the stack, and that's where I'm going to put my shellcode, so execute that shellcode. But just as a placeholder, I'm going to use 4 B's. And so right now, this is like, I don't know, 2012 bytes. It's not that full 3000. I want that full 3000 bytes so I can guarantee a crash happens. So I'm going to send in some C's times 3000 minus the length of everything else we've sent so far. So minus header, minus payload, and minus EIP. Update my buffer. So I'm sending in 2006 A's, and then I want the instruction pointer to be overwritten with 4 B's, just as a placeholder. And then I want, after that, I want to see a bunch of C's. Eventually, I'll replace those C's with my shellcode, right? So we're sending this in, save the file, let's run it. Oops, that's not going to work. I need to close this and restart it because the process crashed. F6, attach it, there we go. Now I can run it, and I should get a crash. Sweet, and we see 424242 is our instruction pointer. Those are our B's. If I do dd esp, display the stack, let's just say 40, we see our C's, right? If I hit T, the single step, just execute the next instruction. Yeah, let me hit G again. Oh, that's not working. Okay, I thought I could just single step into my C's, right? I can't do that yet. I need to jump to the stack, right? So if I do that again, let's say dd esp, the stack starts at this address, 00E1 F9 C3. Can't really just copy in that address and overwrite my B's with the stack address for a few reasons. A, this address might change on the next execution. It probably won't be this same thing. It won't exist anymore. So that's not going to work. And also because it starts with 00. 00 is the null byte. It's a terminating character in the C programming language. So if I go back to this, when it reads in, let's see where it reads in my buffer. So it reads it in here with receive, but it's calling string length and str n compare. When it sees that buffer and it has 00 in it, the null byte, it's going to stop. That's a terminating character. So all my shellcode, all my data is going to be cut off. So I can't use that address for those reasons. I need to find a different address, a more stable one. Or I can choose an instruction like jump ESP, jump to the stack. So no matter what that address is on the stack, just go to it. It's going to change. It might add characters into it. This is called return-oriented programming. How do I find that jump ESP instruction? There's a few ways. Okay, so I want that jump ESP instruction. I can find that with MSF, is it just NASM shell? And I can type in jump ESP, jump to the stack. This is my instruction I want, the assembly. Here's the opcode, FFE4. That translates to jump ESP in x86 assembly code. That's what NASM is. It's the native assembler. It's what x86 and x64 uses. Okay, so we know the opcode for jump ESP, jump to the stack pointer, FFE4. We can't just hard code that in, replace these 4 B's with this. That won't necessarily work. We want to override it with an address, because this is an instruction pointer. So it's going to go to whatever this address points to. So the reason we were getting those errors, because BBBB, it tries to decode that, it tries to dereference it, and that's not a valid address. So it can't find a value to go to. So if I just hard code in FFE4, it's going to do the same thing. It's just going to cause an access violation error. What I really want is a stack address that has FFE4 jump ESP instruction already there. One way you can do this is using the WinDebug search command. Well, let's back up. So we can use the WinDebug search command, but we don't want to search necessarily everything, right? This entire address space here, we see all these modules. Maybe we just want to start by searching one, because they might have bad characters, right? So if I search this first one, VulnServer.exe, we see any addresses begin with 00. That's the null byte. We don't want that. That's going to kill our code. I'm going to take a guess and say I can use this right here, essfunc.dll, because this, we can see this is in the VulnServer master folder, the same as the actual executable. These other Windows System 32 binaries, it might work, but I feel like I might be a little bit safer using the DLL that came with the application. So I'm just going to search this address range right here. So I can say search for a byte in this address space. Ooh, that was ugly. Why did I do that? Search B. Can I easily copy this? Paste it in. And what do I want to look for? FFE4. Hit enter. Okay, see FFE4. If I grab this, hit U for unassemble, that address L2. Cool. Jump ESP. So this is the address I want. Copy that and paste it in. I can't simply paste the address in like this because it's a little endian address, x86 is. So I really want to paste this in backwards, right? So /x AF 1150 and then 62. And I can make a little comment over here saying this is the address. Here's the DLL, and it's jump ESP. So now when I run this program, hit G over here, run Python. Okay, we see this access violation. We see EAX, EBX, ECX, and so on. These are all overwritten with C's, and then it kept going. So that's an error. I mean, this is good, but this is an oversight on my part. I should set a breakpoint to tell it to stop. Hey, don't keep going. I'm going to test this out. Stop at this address. See if I can easily copy and paste this in. Go. I might need to restart the program. Set my breakpoint. Stop at my jump ESP address. Let me make sure it works. Ignore that error. Now I run it. We see breakpoint 0 hit. 625011AF. That's perfect. We can see FFE4 jump ESP. So it's going to jump to the current stack pointer. Let me do a DD ESP. And we see our 3s. Let me hit T, single step. And we see 4.3, increment EBX. So 4.3, the letter C, it's a valid instruction. And you can see it's incrementing EBX. You can see it right here. It's 130. Now it's 131. So it's working. It's executing our code. Now we just wanted to execute shellcode. We wanted to execute something that's going to allow us to penetrate the system and to hack it. So generating shellcode, we can use MSF Venom. MSF Venom payload. Let's say Windows shell reverse TCP. The local host is my host. Let me full screen this bad boy. Here's my IP address for my VM. And I want to connect to this port, 4444, the hacker port. The bad characters are simply no op, the no byte, I mean. The format is Python. And let's just V for variable shellcode. So that's going to take a second to generate. And we see it spits out our shellcode here. So I can just copy this and paste it in to our exploit. Just put it at the top. Now I can update the padding. I want to also minus the shellcode because I still want this to be 3000 bytes. and add my shellcode to my buffer, plus shellcode, plus buffer. Save that. I think it's good practice to add in what the command was to make this. So I'm going to copy this in. So now next time when I look at this code, months or years from now, I can see this is the command I ran to generate the shellcode, and now I know what port I need to open up on my hacking machine. So let's start netcat listener and LVP 4444. Hit enter. So now it's listening. So here's my shellcode. It's going to tell it execute these instructions and call back to my Kali box, my hacker machine on port 4444, and get a remote shell. So we want to see if this works. Python 3 exploit.py. Let me go back over to the Windows machine, exit out of this. I don't want the debugger. Trying to debug your shellcode doesn't always work. One more best practice kind of thing. So it's going to jump directly into my shellcode, right? That's kind of iffy if it works. Sometimes you want to add something called a NOP sled. It's just padding. I'm going to say NOP sled x90. Let's just do like 40. Throw it out there. Add here. Minus length NOP sled. Sled. So the NOP sled, no ops, hex 90, that's just an instruction. It's saying if you see me, do nothing. Just go on to the next instruction. So it's a little bit of wiggle room, it's a little bit of padding. So my instruction pointer, the stack pointer, it'll land somewhere inside here safely, and then it'll trickle down execution, and then it'll execute my shellcode. We can see this in the debugger. Open it up, attach it. I still want my breakpoint at that jump ESP address. Run it. Run this. It doesn't like something. Oh, I forgot to add B for byte. Now when I run it, cool, it hits my breakpoint. I can hit T and I get no op. You can see at the top screen, there's just a crap ton of no op instructions. BD ESP. We see all these no ops, and then it will go into my shellcode. You can see it's written in reverse. So the first character of my shellcode is BE 2F, and we see BE and then 2F and then 7.3 and then 4.3. So this should work. If I just hit G for go, let's see if I get my shell. I do, right? It's a miracle. I can say, who am I? I'm IE user. I can do IP config, and I get this IP address. I can do a directory listing on the C users folder. I have a remote shell. I have access. I'm in. Let me exit out of this. Make sure it works outside of the debugger. Exit. Open this up with no debugger attached. Rerun my exploit code. Oop, I forgot to rerun my netcat listener. And I still have my shell. It still works, right? I can dir. I can create files. I can echo. Ha ha ha. I am a hacker. And put that into a file. lol.txt. And now I can cat out, or not cat, but type that. And I created a file, right? So I'm in. I have full access to the system. I'm not a privileged user. I'm just the user that was logged in, the user who ran the VulnServer application. If I ran it as admin, maybe I'd be the admin user right now. So there we go. That's how we did it. It was a little bit sloppy in the explanation steps, but that's the basics of how you exploit a buffer overflow vulnerability. As a quick recap, it really wasn't that hard. It really wasn't that complicated. We did source code analysis. We looked at the trun function. We saw that it could take 3,000 bytes of data as input, but it can only handle up to 2,000 bytes. To kick that off, you need trun and then a period anywhere in your command to keep it simple. My command is just a period, trun period. It'll call function 3. It's going to pass in 2006 bytes of A. So this could have been anything. This is just junk. This is just data that we don't really care about. It's just padding. It's just filler to get to the instruction pointer. We overwrote the instruction pointer with a jump ESP instruction to go right back to what's on the stack. This was our C's, but we changed that to be a NOP sled, just no op instructions that don't really do anything. It just, hey, ignore me, go on to the next instruction. I put in 40. We could have done more, we could have done less. It's not a huge issue here. And then it just trickles down and it steps into my shellcode. The meat and potatoes, the thing that we really want, the thing that gave us that remote shell, the IE user. And then at the end, we have padding. And this is just to make sure it gets to about like 3,000 characters. I think it's like exactly 3,000 characters. Make sure we crash the program. If I get rid of the padding and I just sent like 2,100 characters, it might not crash. It might not crash reliably. This is just data. This is just bytes on the stack. So I want to make sure I get that crash every single time. Alright guys, there we have it. I hope you enjoyed this. If you did like this, I'll make more videos. VulnServer is a very cool application. There's multiple ways to get remote code execution. This was a vanilla buffer overflow. There's also more advanced ways like structure exception handling overflows. They're using egg hunters. Let me know what you guys think in the comments below. Peace out and see you in the next video.